They're the largest moving vessels ever built. Their length rivaling the height of skyscrapers. Built to carry enough crude oil for the yearly consumption of a small city, the supertanker is a modern Goliath of the sea. Situated along the southern coast of the country, Ulsan is the industrial heart of South Korea. One of her most famous residents is Hyundai Heavy Industries, the world's largest shipbuilding company. Spanning 2,000 acres along the city's waterline, it is the largest in the world, with a workforce of 25,000 that churns out 100 ships a year. That averages to be about one brand new vessel being put out to sea every 4 days. So how are the world's largest ships built? Every ship starts from the yard. The basic building materials of any supertanker, steel plates, are sorted out by electromagnetic cranes. Plasma cutters stand by to cut the plates according to the required shapes. These are then sent to the sub-assembly factory to be welded together.
이 거대한 부열시실을 건조하기 위해서 우리가 편리하고 효율적으로 건조하기 위해서 초기 설계 단계에서 브록을 약 250개의 단위로 브록을 분할합니다.
Supertankers are simply too big to be constructed in one piece. They are designed to be broken down and built section by section. This responsibility falls to the factory assembly lines. They manufacture the sections that will be transported to the dry docks, where they are put together to form the entire ship. Moving these blocks requires a little bit of science, and the shipyard has just the technology to deal with it. Transporters are flatbed vehicles that come in various sizes. The largest of these are 26 meters long by 10 meters wide, weighing 216 tons. They are designed to move weights of between 150 to 1,000 tons. Size aside, transporters can carry out precise driving maneuvers to accurately position the blocks in the shipyard. The dry docks are where the blocks are welded together to build the supertankers. More than 1,000 cranes work to assemble these blocks. The most powerful of these are the gantry cranes, nicknamed the Goliath. The largest are capable of lifting 1,600 tons. And form the memorable backdrop of Ulsan's coastal skyline. Modern tankers adopt a double hull for their structure. In single-hull tankers, the hull of the ship is also the wall of the oil tanks. Double-hull tankers have a second inner hull on both the sides and bottom to minimize oil spills.
그러니까 더블홀이 되면은 선박면에서 보면은 화물량이 좀 작게 실을 수밖에 없고 또 배 자체의 무게는 좀 무거워집니다만은 그만큼 우리가 안전한 화물을 안전하게 나를 수 있는 그런 큰 장점이 있는 것이죠.
A tanker's storage space is also split into many tanks instead of one giant tank. This eliminates stability problems caused by the free surface effect, where oil sloshing from side to side could cause a ship to capsize. Once the dock work is finished, the dry dock is flooded to prepare the ship for sea. The whole process takes about 3 hours. The ship undergoes a complete outfitting at the wharf. Onboard systems and equipment are installed before it goes out to sea for a test trial. Supertankers are built with the most cutting-edge technology available to man. It has to master the ocean to deliver its precious cargo. No such luxury exists for the Pinisi of Indonesia. Age-old traditions are what keep them afloat. And even today, they are built by hand. Since the beginning of the spice trade, Indonesia has sealed its position as an important trading post. For the past few centuries, thousands of Phoenices virtually connected all the islands of the archipelago and formed a major backbone of Indonesia's economy. Lanka and Australia. Fine sailors the Bugis people may be, but these boats are built by the Konjo people from the nearby Bulukumba region. The Konjo boat builders still make the fenices on the beaches in their villages, the same way their forefathers had done so centuries ago. In the 21st century, these methods have remained largely unchanged. The builders work without any drawing plans, but rely on their experience and a good eye for shaping a boat. No welding machines here, just plain open fire. No fabricated parts, just hand-shaped wooden pegs. Traditional rituals and ceremonies rule the shipbuilding process, down to the important laying of the keel of the boat. Work tools are laid out, and offerings are made to bless the boat. Wishes and prayers keep it strong and safe and ensure a smooth construction. The keel is the first piece of wood that the boat builders start with, and the length of the keel decides the size of the boat. The longer the keel, the bigger the boat. Instead of putting in the frame of the boat first, the boat builders begin with the planking. The frame is then fitted into the hull. These ships, therefore, don't rely on their frame for their strength. Although originally sailing vessels, traditional fenices have been motorized since the 1980s. As a result, vessels are reduced to a single frontal mast, used mainly for loading and offloading cargo.
Karena berdasarkan perkembangan kebutuhan, terkadang perahu seperti yang ada di belakang saya ini, orang menyebutnya pinisi. Tetapi tinggal sisa bodinya yang mirip dengan pinisi, sementara terkadang karena dia menggunakan tenaga penggerak dari mesin, dia hanya menggunakan satu tiang untuk persiapan cadangan layar ketika terjadi apa-apa di laut.
With the advent of modernization, true sailing fenices are a rare sight these days. However, one woman has gone back to its roots. American Patty Siri fell in love with the beauty of the traditional fenice ever since she came to Indonesia in the 1980s. Her concern is not only with conserving the original design of the vessel, but also the traditional skills and lifestyle associated with it. For her, there was one clear choice. She had to build her own fenice. The result is Silolona, a 50-meter-long vessel weighing 450 gross tons, capable of carrying 12 passengers and 12 crew. Silolona retains much of the design of a traditional fenice, including the double masts for sailing.
The reason I built Silolona was because I was interested in exploring the corners of Indonesia. And because it's an island nation, a boat made sense, and I also love history. I'm a student of history and wanted to be able to experience Indonesia, and I wanted people to be able to come and experience Indonesia like I did when I traveled doing my research around the archipelago in local traditional boats that belong here.
For the design of Silolona, Patty hired a marine architect from the US and collaborated with Conjo boat builders for the construction. Mixing traditional know-how with modern technology. Silolona stands as an impressive testament to the boat-building skills of the Conjo people. They were so proud of their achievement that the head boat builder decided to stay on as a crew member to take care of her.
Dengan Silolona yang digabungkan dengan sistem tradisi dengan sistem yang modern, itu lebih bagus. Kenapa? Karena sistem itu yang membuat ilmu saya lebih bertambah dan bisa lebih maju. Dengan sistem di Silolona, saya kagum sama Ibu Peti, ya, karena dia adalah salah satu orang yang pertama saya kenal orang Barat, yang saya pertama kali kenal orang Barat. Ternyata dia memang punya jiwa dan punya semangat untuk yang lebih bagus ke depan untuk tradisi saya.
The mission of Silolona is to take charter guests on cultural excursions across the Indonesian archipelago with the experience of sailing aboard a locally built indigenous craft handled entirely by a local crew. For this purpose, she is decked out in luxury. Patty's hope is that traditional Pinisis, like Silolona, can one day be as commercially viable as their ancient predecessors.
They were just at a turning point where if they didn't switch from cargo and come over to passenger, that the tradition is in danger of being lost. It is in danger of being lost. But now that there's a market for high-end travel and discovering Southeast Asia and the vessel of the Spice Island trade, I think they're going to survive.
Thanks to the efforts of people like Patty, the traditional Pinisi has found a new lease of life. To maintain its existence, the Pinisi must adapt and reflect the needs of the modern world. This is a lesson that supertankers have come to learn. Modern supertankers are highly adaptable, responsive floating pipelines. Modules can be switched to add or reduce capacity, taking advantage of price fluctuations at a moment's notice. With oil being a hotly traded commodity, the adaptability is necessary. South Korea employed that adaptability to their advantage in their bid to overtake Japan as the world's largest shipbuilding nation.
Japan tried to reduce the capacity and tried to standardize the ship model, and they asked the ship owners to buy their standardized ship model. Korea was not. We were very flexible, and in a sense it's a custom friendly ship designs. Very flexible designs to fit the requirements by the ship owners.
But South Korea is already looking over its shoulder at China, which has embarked on a path towards overtaking them by 2015.
China is a bona fide competitor in the international shipping market. But the Korean shipbuilders in the meantime have been focusing more on building high value-added, sophisticated ships, and also demand higher technology.
One of the new Korean technologies that has been developed over recent years does away with dry docks altogether by building large ships on the ground. This new method of on-ground shipbuilding cuts down on the number of steel blocks needed, improving the production efficiency and reducing the time needed for assembly. the supertanker's ability to adapt is essential if her precious cargo is to continue being delivered around the world. She can take heart in the Pinisi of Indonesia, which have survived the changes of half a millennium. It is a vessel that has stood the test of time and secured the distinction of having shaped Indonesia's economic and social past. Two ships built for the same purpose. One, a Goliath of the ocean. The other, a survivor of the sea. It's Mumbai's longest, highest, officially the city's first viaduct, and its first roadway to have two tiers.
Mumbai Urban Transport Project was basically designed to ease the traffic situation in Mumbai. And Santa Cruz-Chembur Link Road is a very important part of this entire Mumbai Urban Transport Project because it is reducing the traffic time by almost 90%.
A new kind of transport infrastructure model. It is nothing short of an engineering marvel. Thousands of miles away in another country, archaeologists discover a complex network of roads dating back to the 11th century. The 225-kilometer-long roadway was part of the ancient Khmer highway, connecting Angkor to its neighboring towns. Two densely populated cities, two different eras, united astonishingly by one vision. Mumbai, the world's second most populous city and India's bustling commercial capital. With an estimated population of 18 million and growing exponentially, it's also the world's most crowded city. Picture this. 90% of Mumbai's commuters use the city's public transport daily. They navigate through a densely populated area of roughly 30,000 people per square kilometer. Crowded city. Groaning infrastructure. The result? Mumbai's worst nightmare. And unquestionably, its biggest challenge. How can the city cope?
SCLR is one of the important east-west corridors in Mumbai. If you look at Mumbai as a whole, the traffic is predominantly north-south. What's also happening is towards the east of Mumbai, there's a whole new city that's developing, which is called the Navi Mumbai. So increasingly the traffic is going to be required to go from the west to the east. And Santa Cruz-Chembur Link Road is one of those east-west corridors.
The Santa Cruz-Chembur Link Road, SCLR for short, is a critical link in concrete and steel, connecting the bustling east and west zones of the city. It is part of a $1 billion Mumbai urban transport project. The total length of the SCLR is 6.5 kilometers, of which the initial 3 kilometers is being developed with local government funds. The remaining 3.5 kilometer section of the road is funded by the World Bank to a tune of $975 million. This is a critical section that consists of a 1.5 kilometer double-decker viaduct that crosses two very busy railway lines. The different levels, including the ground level, lead to 3 different areas of the city, thus reducing traffic congestion significantly. At its highest point, the SCLR is about 20 meters high. That's as high as a 6-story building. It is designed to connect north-south arterial roads, as well as railway and bus stations, thereby integrating various modes of public and private transport. The new expressway is expected to solve some of the worst traffic bottlenecks in Mumbai. But it all sounds far simpler than it seems, because the real challenge is not one of engineering, but really one of logistics.
It's like doing a bypass surgery on a say a living tiger without anesthesia, because SCLR in many ways is like doing a bypass surgery through the city of Mumbai. You're trying to create a whole new artery for the traffic to flow through an alternative route.
It's about building a road over existing roads. Building a road bypassing innumerable settlements. Building a road over railway tracks with trains crisscrossing every 2 minutes. Building a road that potentially displaces 4,500 families and possibly disrupting many small businesses. Now, these are the challenges. Monumental, unprecedented, and transforming a construction project into a logistical nightmare.
So this is basically the alignment of the Santa Cruz-Chembur Link Road. It's actually not the full alignment, but most of the alignment that we are dealing with on our project. This section is about 3.5 kilometers. And if you looked at a 3.5 kilometer road, you would virtually say, heck, that's a cakewalk. You know, that's not a big project you're dealing with. But when you start taking a closer look at it, and that's when you start looking at this map more closely, is when you start appreciating some of the challenges we are addressing on the project.
Requiring a land area of nearly 48,000 square meters, the task of building an expressway is easier said than done. One of the first steps includes land acquisition. A humongous task. Take, for example, this area that buzzes with activity 24/7. This is the beginning of the World Bank-funded section of the expressway at Miti River, Kula. Don't be deceived by its looks. These are shops owned by scrap metal dealers who are believed to produce a daily turnover of nearly $500,000 US. And these shops need to be moved to accommodate the new expressway. What could be the motivation for the scrap metal dealers to move? Can the resettlement option promise similar income or more? There are obviously no easy answers to these questions.
Compared to what we can observe in other cities in the world, the challenge here are posed by the land acquisition and the resettlement are really enormous.
Mumbai city is growing faster than its infrastructure can keep pace with. Building a new road inevitably means displacement of people. But whether they are fairly compensated is really the big question. Several thousand miles away, in another country, going way back into the past, the ancient city of Angkor, a bustling capital of 1 million residents, witnesses the construction of a complex network of roads. Cambodia, a country with a history both inspiring and depressing. What comprises present-day Cambodia came under Khmer rule around the 7th century, when the region was at the center of a vast empire that stretched over most of Southeast Asia. More precisely, what is now known as Thailand, Laos, and Vietnam. The Khmers were great builders, Deep in the jungles, 1,000 temples testify to the splendor of an ancient empire that lasted for more than 600 years. The abandoned city of Angkor is indeed one of the world's great wonders. But apart from the temple complexes, the Khmers have today come to be known for another architectural feat: their complex road network. With the advent of GPS and satellite systems, space and aerial views are now shedding light on immense highways built between the 11th and 13th centuries AD. Experts are only just beginning to map out the Khmer transport network that incorporated canals, laterite stone bridges, and roads. That these structures managed to survive the attrition of time is made all the more amazing by the fact that every single structure was built entirely by hand. The ancient road east of Siem Reap is part of a network of roads built by Angkor's rulers to connect the capital with all the major outlying cities. Today, the road is forgotten, used only by ox carts and cowherds, though along its length are ancient bridges and temples waiting to be rediscovered.
120 kilometers in Thailand territory nowadays completely ruined. We cannot find out the evidence of the road. But in Cambodian, we can find out 32 ancient stone bridges and about 60% in Cambodian territory.
In the 12th century, King Jayavarman VII built highways that had few equals on earth. They can be seen from satellite photographs, with the longest running some 220 kilometers northwest of Phi Mai in modern-day Thailand. This image, taken from the Space Shuttle Endeavour, shows the area around the huge ceremonial complex of what was once the ancient city of Angkor. The picture reveals new settlement data on this major Khmer site, which once held more than 60 temples and 1 million residents dating between the 9th and 15th centuries AD. The city was organized around several vast reservoirs, interconnected by canals used for transportation and irrigation throughout the entire central zone. Today, most of the region around the main temple complexes is covered by rainforests. Aided by the new radar satellite imagery, the areas north of Angkor Thom are now yielding up secrets of previously unknown structures and canals. The satellite data is being used by archaeologists to trace the city's evolution over 800 years and to reconstruct the vast network of roads. Nearly a millennium ago, the road would have been a major artery of the Khmer Empire. Flying over these areas reveals the extent of Angkorian transport logistics. Today, the roads have been mined and bombed almost out of existence. But it's time to restore the roads. And the process has already begun with the removal of 25,000 landmines. The Ministry of Public Works and Transport has also built bypass roads with new bridges around the old ones to divert traffic off the ancient bridges and onto the new roads. But the process of restoration is not without delay. For one, there is the painstaking process of the removal of landmines. Added to this is the fact that most of the ancient road is hidden under vegetation or underwater during monsoons, thus impeding the restoration process. In India's most crowded metropolis, Mumbai, the city administration is busy building its first double-decker expressway to ease traffic congestion. But there is one major bottleneck.
WADA to do some social world line excavation and it has to be expedited.
You give me a call.
2 years behind schedule now, and only about 30% complete. A meeting scheduled between engineers and contractors may finally see work picking up on the Santa Cruz-Chembur Link Road, or SCLR as it's called.
Because every day is very important.
Already 5 years since commencement of work, the project employs over 1,500 workers and will cover nearly 48,000 square meters of the city's land area.
Yes, the project did start in 2003. It was anticipated they would complete by 2005 or 2006. But in this sort of environment, the democratic environment that we have in India, when you get on to doing projects, you have to get the buy-in of the stakeholders. And the stakeholders are not just the authorities, but also the project affected people, for instance. And there's about 5,000 project affected people that live along this road.
Picture this. Mumbai city lies along a narrow peninsula and has an exceptionally large number of people living in unauthorized settlements, many on public land. More than 6 million people live in the city's slums. So imagine a link road that would cut across these settlements. This would mean acquisition of the encroached lands and resettlement of the people displaced. And resettlement is never an easy task.
This is the apartment built for those slum dwellers. Now it's occupied, already occupied, more than 3,200 families who's affected by Santa Cruz-Chembur Link Road. I think more than 700 commercial structures were affected, and these are the commercial structures were given for these people.
The task of resettlement has been painstakingly done. It is also a major achievement and perhaps a positive outcome of the SCLR project.
Not a single settlement is done by force or taking help of police. It was done amicably, and World Bank is keeping close watch on the resettlement.
As if resettlement isn't tough enough, there are post-resettlement issues, such as supplying electricity and water to new dwellings, providing them access to transportation, overseeing the cooperative societies. In short, just managing their daily needs.
यहाँ वाटर प्रॉब्लम है, लिमिटेड पानी आता है, कभी कभी ऐसा होता है एक दिन आता है, दूसरे दिन नहीं आता, कभी कभी ऐसा होता है कि आता भी नहीं। ये अच्छा, दूसरी बात ये है, वहाँ से हम लोग जब निकलते थे तो पैदल एक 5-7 मिनट के अंदर स्टेशन पहुँच जाते थे और वहाँ से पूरे बम्बई में कहीं भी जाना हो जाता था। यहाँ पे या तो रिक्शा पकड़ें या तो पैदल ट्रैक क्रॉस करके जाओ स्टेशन, तब है।
These are real issues that will have to be addressed by the project leaders in conjunction with NGOs working in these areas. But the toughest, most trying part of the project isn't resettlement. It lies here, at the point of intersection where the expressway hits a railway line, and therefore has to go over the tracks. It may sound simple, but it's one enormous challenge, putting engineers to their ultimate test.
So this is one of the toughest sections of the SCLR. This is where we have a span of almost about 120 meters that we have to cross over these rail tracks. And there's a train moving every 2 minutes with about 5,000 people. So that's almost equivalent to building a 40-story building on its side. And this is where we have to get special permission from the railways to try and get what's called a block. And most of the work will be done during early morning or late at night. And this is where we'll probably find some of the most challenging moments of the construction of SCLR.
Perhaps it's a case of history repeating itself, but with a modern twist. Ancient Cambodia built its roadways to develop trade routes, and through these wield control over farther shores. Modern Mumbai has been growing in leaps and bounds, with the infrastructure only now being developed to cater to this phenomenal growth. But what seems to be displacing and relocating people may well change the face of Mumbai for good. The Santa Cruz-Chembur Link Road does not just connect different parts of the city, but also really connects people living along its path.
It's a common thread between communities. If you go from one end to another, you'll see all sorts of religious denominations, all sorts of working class types of people, different commercial enterprises. And I think in that sense, SCLR is a common thread that's going to connect them. Neighborhoods that were divided virtually, you know, as one would say, you lived on the other side of the tracks. And this is connecting all of those people.
For Mumbai, this link road, through a logistical nightmare, is an absolute necessity. One that will not only ease traffic bottlenecks, but also prepare it to face the future with pride.